formula. Solve the equation 6x squared plus x minus 15 equals to 0 using the quadratic formula and another method. First of all, let's use another method. And if we are using another method here, we are factorizing because this is look is a factorable, and we are multiplying 6 by 15, and we convert this equation in more convenient equation, which is x squared plus x, and 6 times 15 is 90 minus 90. So now I'm taking some shortcuts in this method, and now I'm looking this 90 because I multiplied a times c, and I am factorizing. This can be different factors, but one of the good factors then when I factorize 90, and I'm going to get here 1 is 10 and 9. 10 times 9 is 90, so it's a 10 and 9. Because it's a plus 10 minus 9 is equal with 1, so I get the sum here 1, and this I can factorize with one step, with one shot here. X plus 10 times x minus 9 times x minus 9 is equal to 0. But because I multiplied here with the a, so I'm going to this to divide the last number by 6. A was a 6 because I multiplied by this 6 here, and this I divide by 6, and now in the simplest form, x plus 5 divided by 3 and here is a time x minus 3 divided by 2. When I simplify, everything is equal to 0. And as a solution I can take those x, so I'm taking a shortcut because I have to equate x plus 5 over 3 divided x plus 5 divided by 3 equal to 0, and I solve for x. But as a shortcut, because here is a positive, I'm taking here negative 5 over 3. I'm putting the other side, so I'm going with one simple step. And the other one here, x is a negative, so x, the other solution, is equal to the opposite sign, whatever we have in factorized form, is a 3 over 2. So I'm just putting in the other side and I'm changing the sign. So those are the solution for this quadratic equation. But if we want this equation to solve it with the quadratic formula, let's say x is here. Let me write just the one fraction form. So I'm going to apply this formula. But here, the coefficient in the front of the leading coefficient is 6. This is the a. So this is the, but here is invisible 1. So here is 1 instead of before the x is a b. And the last constant here is a c. And now I'm taking this coefficient here, and I'm plugging in here in the formula. Here is a minus b, but b is 1, is minus 1. And here is a plus minus. Because b is 1, now I'm going to plug in this equation. B is 1, here is 1. And 1 square is not going to change a lot of thing because 1 square is already 1. Minus 4, and instead of the a I'm plugging here 6, and instead of the c I'm plugging here 15. And now I can multiply everything in this formula here, and when we multiply everything here we get the numbers. And here is a 6 times 2, or 2 times 6, which is 12. But as we see here in a quadratic formula, we have a lot of calculation to do it, and you can you can compare and see whichever is better. And 1 square is 1, and if you multiply here, but here is a negative c, here is negative, we have to write here negative. Negative times negative is a positive. So first of all, we take care of the sign. And 4 times 6 times 15, when you calculate in calculator, you get 360. And here 2 times 6 is a 12. And when we do some arithmetic work here inside, minus 1 plus minus. When we do some arithmetic work, we come to this form. 1 plus 360 is 361. Square root of 369 is a 19 divided by 2. When we do everything, then x we get is equal with minus 5 over 3. We're going to get the same result. So I'm not going in every step because it takes us a longer time. But we can see in both methods has to produce the same results, and you can see whichever you think is more convenient, you can use that method. Because sometimes when a quadratic equation is not factorable, we can use a quadratic formula, which in factor form we cannot solve it. But like is whenever is in a factorable form, the quadratic equation is better to use a factorization because we can solve it for a much shorter way.